Every night, a familiar celestial body graces our sky, the moon. For centuries, it has captured the imagination of humanity, inspiring myths, guiding explorers, and influencing the tides. But beyond its romantic glow, the moon is far more than just a distant companion. It holds secrets of the early solar system, the origins of our planet, and the potential for our future in space exploration. As the fifth largest natural satellite in the solar system and the only one of Earth's, the moon plays a crucial role in stabilizing Earth's axial tilt, controlling the tides, and influencing the development of life itself. It is not just a silent observer, but an active participant in our planet's history and its future. But how did this enigmatic celestial body come to be? And why does it matter to us so profoundly? To understand the moon, we must travel back 4.5 billion years, when the solar system was still forming. Earth, at this time, was a hot, molten world, frequently bombarded by asteroids and other space debris. The moon was born from one of these catastrophic impacts, an event so violent it reshaped both the moon and Earth forever. Imagine the chaos of this time. A young Earth under constant attack from space rocks. A world just beginning to solidify. Then, in a brutal clash with a Mars-sized planetesimal named Theia, Earth suffered an impact of unimaginable violence. This cataclysmic collision unleashed a torrent of heat and energy, vaporizing material and flinging molten rock into space. Out of this chaos, the moon was born. How did Earth survive such a violent impact? The shockwaves would have been enough to rip apart any other planet. Yet somehow, Earth endured and slowly healed. The collision also tilted Earth's axis, setting into motion the planet's own evolution. As the impact gave us our seasons and day-night cycle, the very conditions for life began to emerge. As the debris cooled, the moon formed, but it wasn't the serene, pale sphere we see today. It was a molten, violent place, constantly bombarded by asteroids and covered in lava flows. And yet, as it cooled, it settled into a quiet orbit around Earth, becoming the stable presence we know today. The composition of the moon suggests it's largely made from Earth's outer layers, which were vaporized during the impact. The shared chemical makeup of oxygen isotopes between Earth and moon rocks supports this theory. Additionally, the moon lacks a large iron core, unlike Earth, suggesting its formation was primarily from Earth's crust and mantle. The moon's gravitational pull has a profound influence on Earth. While it's only 1/80th of Earth's mass, its gravitational force exerts an outsized effect on our planet. Perhaps the most obvious effect is the creation of ocean tides. The moon's gravity pulls on Earth's oceans, causing the water to bulge toward it. This creates the high and low tides that we observe, but the moon's influence goes far beyond the ocean's edge. One of the most critical roles the moon plays is stabilizing Earth's axial tilt. Without the moon's gravitational influence, Earth's axial tilt would vary dramatically, swinging between 0 and 85 degrees over time. Such fluctuations would lead to severe climate changes, including dramatic temperature shifts, making Earth less hospitable for life. The moon's steady pull has kept Earth's tilt stable for billions of years, providing a climate conducive to the development of complex life. The moon also affects Earth's rotation. As it orbits Earth, the moon's gravitational pull causes tidal friction that gradually slows Earth's rotation, lengthening our days over millions of years. This process, known as tidal braking, has already increased Earth's day from about 6 hours in the early Earth-Moon system to the 24-hour day we experience today. Meanwhile, the moon itself is gradually moving away from Earth at a rate of approximately 3.8 centimeters per year. The moon's presence has also acted as a shield for Earth. Over the course of billions of years, the moon has absorbed many asteroid impacts that would otherwise have struck Earth. Some scientists suggest that without the moon's gravitational influence, Earth may have experienced many more catastrophic impacts that could have hindered the development of life. Humans have always understood the moon's influence, especially sailors, who used the moon to navigate vast oceans, relying on its phases to mark time and direction. Ancient civilizations like the Babylonians, Egyptians, and Mayans built their calendars around the moon's cycles, which helped them track seasons and harvests. The moon wasn't just a celestial body, it was a guiding force for life on Earth. For centuries, the concept of the dark side of the moon has captured the imagination of people around the world. But contrary to popular belief, the moon doesn't have a permanent dark side. It is instead tidally locked to Earth, meaning one hemisphere constantly faces our planet, while the other is always hidden from view. This phenomenon occurs because the moon's rotation period is synchronized with its orbital period, taking approximately 27.3 days to complete both. Despite the science, our fascination with the far side of the moon has always transcended the purely astronomical. Throughout history, the dark side became a symbol of mystery, isolation, and the unknown. In literature, the far side was often associated with forbidden knowledge, an alien world lurking just out of reach. In music, songs like Pink Floyd's The Dark Side of the Moon have captured our cultural obsession, blending the real and the imagined. Early astronomers believed the hidden hemisphere might harbor alien life or strange phenomena. It wasn't until 1959, when the Soviet Luna 3 mission sent back the first photographs of the far side, that humanity saw its true nature. Unlike the familiar near side, which is covered with large, smooth plains called Lunar Maria, the far side is heavily cratered and rugged. The moon's thick crust on the far side prevented volcanic activity that could have resurfaced the region with lava flows like the near side. Today, scientists are considering the far side of the moon as a potential location for future deep space radio observatories. Because the far side is shielded from the radio interference of Earth, telescopes placed there could provide a clearer view of the universe's earliest signals, potentially unlocking new insights into cosmic history. While the moon's surface is what we observe from Earth, it is the hidden layers beneath that tell the most intriguing stories about its formation and history. Beneath the rugged surface, the moon holds secrets about the early solar system, the cataclysmic impacts that shaped it, and the dynamic processes that continue to unfold even today. Imagine standing on the moon's surface, gazing at the dark expanse of space, knowing that directly beneath your feet lies a world with a complex internal structure waiting to be explored. Much like Earth, the moon is made up of distinct layers, each with its own unique characteristics and mysteries. The moon's outermost layer is its crust. It's a hard, rocky shell, but much thinner than Earth's crust. Stretching about 30 to 40 kilometers beneath the surface, this crust is largely made of silicate minerals, with a high concentration of aluminum and calcium. Beneath the crust lies the mantle, a thick, dense layer that makes up the majority of the moon's volume. Unlike Earth's mantle, which is composed of rock that is semi-fluid and capable of movement, the moon's mantle is mostly solid, although it still behaves like a viscous material over millions of years. The mantle is rich in iron, magnesium, and silicates, which are crucial clues about the moon's early volcanic activity. Seismic data gathered from lunar missions, including the Apollo missions, has provided crucial information about the mantle's composition. These findings tell a story of a moon that was once hot and molten, with the heat of its formation driving early volcanic activity. Below the mantle lies the moon's core. This is the least understood part of the moon, primarily because it is buried so deep beneath the surface and is difficult to study directly. Unlike Earth's core, which is divided into a liquid outer core and a solid inner core, the moon's core appears to be smaller, partially molten, and much less dynamic. Interestingly, some evidence suggests that the moon's core might still be cooling, and there may be tiny pockets of molten rock inside. While the surface of the moon is a familiar sight, understanding these internal layers is crucial to piecing together the moon's origin. As we continue to explore the moon, we unlock more pieces of its story, one that has been written in the rocks and dust of its surface, but also deep within its mysterious interior. We often take the moon for granted, but what would Earth be like without it? The consequences would be catastrophic. Without the moon's gravitational pull, Earth's axial tilt would become unstable, fluctuating wildly between 0 and 85 degrees. Over time, this would lead to extreme climate shifts and chaotic seasons, making Earth much less habitable. The moon's influence on Earth's tides is also critical. The ebb and flow of the tides help stir the ocean waters, mixing nutrients and supporting ecosystems that rely on tidal movements. Without the moon, Earth's tides would be much weaker, disrupting marine life. Beyond that, many species, including nocturnal animals, have adapted to the lunar cycle. The moon cycles have also influenced human civilization, from ancient timekeeping methods to agricultural planning. What if humanity had never gazed up at the night sky and wondered about the moon's mysteries? The moon has always been part of our stories, our myths, our understanding of the cosmos. What would the world look like without it? As humanity's understanding of the moon evolved, so too did our desire to reach it. The ancient myths of gods and celestial beings were replaced by scientific curiosity and ambition. Our fascination with the moon became not just a story of wonder, but a quest for knowledge and understanding. The Apollo program, perhaps the most iconic achievement in space exploration, marked the moment when human hands first touched the lunar surface. On July 20, 1969, Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon, forever altering our relationship with this distant world. But the Apollo missions weren't just scientific endeavors, they were a triumph of human spirit, a testament to what we can achieve when we reach beyond the confines of our world. The moon landing was a global event, watched by millions, bringing people together in awe and wonder. It was a moment of shared experience, one that united humanity in our collective dreams of exploring the stars. Before the Apollo missions, our ideas about space were speculative, based on myths, philosophies, and the work of early astronomers. Yet in a span of just a few decades, humanity went from stargazing to stepping on the moon. This journey reshaped not just our understanding of the moon, but our place in the universe. The Apollo missions also provided us with critical scientific data, helping us understand the moon's composition, its geological history, and its relationship to Earth. We learned that the moon was once volcanically active, that its surface was shaped by asteroid impacts, and that it had a history remarkably similar to Earth's. But despite all this new knowledge, the moon still holds many secrets, waiting for the next generation of explorers. Today, the moon is more than just a symbol of past triumphs, it's a stepping stone toward the future. The Artemis program, set to return humans to the lunar surface, is not only a new chapter in space exploration, but a reminder that the moon is not just a destination, it's a launchpad for humanity's next great adventure into the cosmos. Looking toward the future, the moon is no longer just a place for scientific study, but a potential home for humanity's next great frontier. The dream of lunar colonization is becoming increasingly tangible, with advances in technology and international collaboration opening the door to a new chapter in space exploration. Why the moon? The answer lies in its proximity to Earth, its resources, and its potential as a launching pad for deeper space exploration. The moon offers a wealth of materials, like water ice, which could be used for life support or converted into fuel, and its low gravity makes it an ideal location for testing technologies that could one day take us to Mars and beyond. However, colonizing the moon is not without its challenges. The moon's harsh environment, its extreme temperatures, lack of atmosphere, and constant bombardment by cosmic radiation presents significant obstacles for human settlement. We'll need to develop new technologies to protect astronauts from these dangers, create sustainable habitats, and figure out how to grow food and generate energy on the lunar surface. Perhaps the greatest challenge of all will be adapting to life in the moon's low gravity. The moon's gravity is only 1/6 that of Earth's, and prolonged exposure could have profound effects on the human body. Astronauts would need to adjust to this new environment, with all the physiological and psychological implications that come with it. Yet the potential rewards are enormous. Lunar bases could serve as test beds for technology that will be critical for long-duration missions on Mars, and could pave the way for a permanent human presence in space. The moon may one day be a stepping stone for the human race to explore other worlds, to push beyond the bounds of our solar system, and to become an interplanetary species. But as we look to the moon's future, we must also ask, what does it mean for humanity to colonize another world? What responsibilities do we have in this new era of space exploration? The moon will undoubtedly change us, not just in terms of technology, but in how we view our place in the universe. As we look toward the future of space exploration, the moon will play an increasingly pivotal role. It is not just a place of scientific curiosity, but a launchpad for humanity's next great leap into the cosmos. The moon's future, however, is not just about exploration and colonization, it is about understanding our place in the universe and what it means to be human. Over the next few decades, the moon will continue to serve as a testing ground for technologies and systems that will be essential for future missions to Mars, asteroids, and beyond. The lunar surface will provide us with valuable resources, including water, which could help sustain human life during extended missions. But it's not just about using the moon to get to other places, it's about exploring the moon itself, uncovering its mysteries, and unlocking the secrets it holds. One of the most exciting possibilities is the prospect of mining the moon. Its surface is rich in valuable minerals and metals, such as helium-3, which could one day be used in nuclear fusion, and rare earth elements, which are critical for modern electronics. If these resources can be harvested, they could help fuel future space exploration, and even provide materials for industries back on Earth. The moon also represents a new frontier for human imagination. As we push the boundaries of space exploration, the moon serves as a beacon, reminding us of the incredible potential of human ingenuity. What we achieve on the moon will set the stage for what comes next. Will we build bases on Mars? Will we explore the moons of Jupiter and Saturn? The moon is not just the end of the journey, it's the beginning. In this new era of space exploration, humanity will confront challenges and make discoveries that will shape our future. What does it mean for us to venture beyond our home planet, to leave behind the Earth and live among the stars? The moon will help us answer this question as we take our first steps toward becoming a multiplanetary species. The moon has been a constant companion to Earth for billions of years, playing a fundamental role in shaping our planet. Its gravitational pull governs the tides, stabilizes the Earth's axial tilt, and helps create the conditions that allow life to thrive. The moon has also inspired humanity's curiosity, sparking countless myths, guiding early explorers, and even influencing the development of our civilizations. Throughout history, the moon has been a symbol of mystery and wonder, its presence in the night sky sparking both awe and imagination. As we look to the future, the moon remains more than just a distant object hanging above us. It is not only a reflection of our past, but also a symbol of our potential and aspirations. The next frontier in human exploration is no longer confined to Earth. It is the moon that stands as the gateway to the stars. The idea that our first steps into deep space will be taken on lunar soil is no longer a far-off dream, but an imminent reality. The moon represents the spark of human ingenuity, the drive to overcome challenges, and the constant yearning to reach further into the unknown. We've come so far since the first stargazers marveled at the moon's glow. The journey of exploration from ancient times to the Apollo missions and beyond has brought humanity closer to understanding our place in the cosmos. Yet, we are still at the beginning. The moon's significance transcends science. It embodies the spirit of adventure, resilience, and the desire to go beyond our limitations. As humanity ventures into the vast expanse of space, the moon will continue to play a pivotal role. It will be our first stop on the path to Mars, the outer planets, and beyond. The challenges of lunar colonization, resource extraction, and scientific research on the moon will lay the foundation for the next great leap in human history. The moon is not just a symbol of where we've been, it is the beacon guiding us toward where we are going. The moon will always be with us, a reminder of the incredible journey we've made and the extraordinary future that lies ahead. GAP 2.0S.